What is a radian? So back in the day, some guy decided we're going to use degrees to talk about circles. They decided we're going to use 360 degrees simply because it's a really nice number that can be divided by a lot of other numbers. So that's why 360 degrees is our amount of degrees in a circle. But it's not the most accurate or technical way to measure angles in a circle. So there's this other guy called a radian. So a radian is an angle measure, and it is how far around the edge of a circle you can make it with one radius. So if I lay one radius on the edge of this circle, it's the angle I make by forming that. And we tend to talk about it in terms of pi, because if we laid our radius on there, we would figure out that all up there are 2 pi radiuses. So we're going to say 2 pi radians in a full circle, because we know the circumference of a circle is 2 pi r. Someone very smart has already figured that out for us. So 2 pi radians is how many fit around. It's about 6.3. So if we physically measured it, that's what we get. So what's really nice is we now know that 2 pi radians equals 360 degrees. So if I wanted to know how many degrees is in 1 radian, I would divide this side by 2 pi, which means I also divide this side by 2 pi. 360 divided by 2 is 180, and divided by pi, there we go. So 1 radian is equal to 180 on pi degrees if we were to stick it in a calculator. So we'd get an actual number for it, but we tend to talk about 180 on pi. If I wanted to go the other way, so I wanted to know how many radians in 1 degree, I would divide this side by 360 to get my 1 degree, divide this side by 360. So now I have 2 on 360, which puts my 180 on the bottom, pi on the top. And this is really handy to know, because this is how we can convert between radians and degrees. These two definitions are on your cheat sheet. It actually tells you how to convert from one to the other, which is what we're going to do now. So I want to be able to convert between degrees and radians. So if I had 1 radian and I wanted to turn it into a degree, well, I know that there is pi on 180. There is 180 on pi degrees in 1 radian. So I just times the number of radians I have by 180 on pi, and that's my answer. Really easy for our first one. So over here, 2 radians. So I would take 2 radians and times it by 180 on pi, which is going to get me 360 on pi degrees. Okay, so this one. Generally when we're talking about radians, they're going to have some sort of pi involved. So for this one, we want to turn 9 pi on 10 radians into degrees. So we multiply by 180 on pi, and then we can do some cancelling because they're fractions. So pi cancels with pi, 10 cancels down. So now I have 9 times 18. And 9 times 18 equals 162 degrees. So that's how we can convert from radians to degrees. And don't forget, it is on your cheat sheet. So we know in how many radians there are in degrees, because we did that on the last slide. We know there's 180, pi on 180 radians in 1 degree. So if I want to go from degrees to radians, all I do is take my number of degrees and multiply it by pi on 180. Then I want to cancel down. Do I have any common factors? 15, 16, 17, 18. So that's dividing it by 2. Divide this one by 2 gets me 90. Divide them both by 9. So 38 degrees is the same as 2 pi on 45. We try and simplify it as much as we can. So same with the next one, 150 times pi on 180. Well, I would cancel the 10s to start with. Then I know there's 3 in both of these. 6 3s there. and 5 3's there, which gets me 5 pi on 6. So that's how we do radians. So they're the questions I suggest you do. Okay, so we also want to be able to draw radians on our circle. So these ones here are all our on 3's. So we can convert, and we know 60 degrees equals pi on 3, 120, 2 pi on 3. So we can see that. We can also actually draw them in. So the thing that's really nice is if it's on 3, pi on 3, we know 2 pi is over here because we've gone the full way around our circle. We also always start here because 2 pi and 0 are the same spot, and we go anti-clockwise. So if 2 pi is there, that means pi is over here. So we also know this is 360 degrees or 180 degrees. So we want to be able to break up our sections. So all our 60 degrees are break down into something on 3. So pi divided by 3, that's our base angle. And it tells us we're going to split our circle, our top half, the semicircle, into 3 sections. So all up, if I was going 360 degrees around, which is 2 pi, I need to split my circle into 6 lots of 3. So 6 thirds around my circle. So that's how I draw in radians. So this is pi on 3 degrees around, or radians around. To get here, that's 2 pi on 3, because I've gone 2 pi on 3's around. This one, the full angle, 3 pi on 3, which is the same as pi. And I can keep doing that, so I can keep talking about how far I've gone around. So the next one, all the way around to here, is 1, 2, 3, 4 pi's on 3. So that would be the full angle from 0 to where I've gone. And that's how we draw in pi's on 3's. You can have a code doing it for 45 degrees and 30 degrees, which is pi on 4 and pi on 6. See if you can do them.